Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back. And today we're going to review and do a review lesson about the Pythagorean Theorem and the converse of the Pythagorean Theorem. So let's go ahead and hop on in. Okay. Now, the Pythagorean Theorem, you only use it for right triangles. Okay. The Pythagorean theorem clearly states that a squared plus b squared is equal to c squared. Now, another way of remembering that is that when you're given a right triangle, you square the value of each leg. A and B are legs. And then you add that and it should be equal to the square of the hypotenuse, the third side, okay? C is always the hypotenuse. A and B are interchangeable when you label a triangle, okay? C is always the hypotenuse. The hypotenuse is always opposite the right angle. So, for example, here's the right angle. C is going to always be opposite the right angle, okay? Or the hypotenuse is always opposite the right angle. Now, so the Pythagorean theorem is a squared plus b squared equals c squared. And you use that if they give you two legs because you use the Pythagorean theorem to find the hypotenuse. However, sometimes we have to use what we call the Pythagorean theorem converse, is when they give you the hypotenuse in one of the legs and you have to find another leg. Okay? So the converse is c squared minus b squared equals a squared. Now, you may see some people write it as c squared minus a squared equals b squared. As I stated before, a and b are interchangeable. They both represent the length of a leg. Okay, so it does not matter how you write the converse. Okay. Now let's go ahead and take a look at number 12. And for the purpose of this, I'm gonna separate it a little bit, just so we have some distinction there. All right. So, number 12 says, for all four of these, which side lengths form a right triangle? So, if I'm trying to figure out which ones form a right triangle, okay, I have to basically use the Pythagorean theorem. So, Pythagorean theorem, we do a squared plus b squared equals c squared. So, for this first one, this is a is the smallest, b is the middle number, and c is always the largest value. And if you need to, you can go ahead and just label all of them so that way you know. And remember, technically speaking, you could interchange A and B, okay? But for the sake of this, A is the smallest, C is the largest. Now, we just want to see if all of these fit the Pythagorean theorem. So 16 squared plus 30 squared is supposed to equal 34 squared, okay? So let's see. I'm gonna pull out my calculator here. 16 times 16, that's 256. Okay, 256 plus 30 times 30, which is 900. And now we gotta do 34 times 34, which is 1156. And all I need to do now is do 256 plus 900, and that equals 1156. So because both of these, 1156 is equal to 1156, then that means that the first set of numbers actually make a right triangle. Let's take a look at the next group. So we have 12 squared plus 19 squared equals 23 squared. Okay, so 12 squared is 144. You should know that already. 19 squared is 361. Okay, and 23 squared, 23 times 23, that is going to be 529. Now I just want to do 144 plus 361, that equals 505. And 505 is not equal to 529. So these do not make a right triangle. Let's take a look at the next group. We have 8 squared plus 20 squared is supposed to be equal to 22 squared. 8 squared is 64. 20 squared is 400. And 22 squared is 484. And if we do 64 plus 400, that's 464. But 464 is not equal to 484. So that group of numbers does not form a right triangle. Last set of numbers. We have 10.5 squared plus 14 squared is supposed to be equal to 17.5 squared. Now, 10.5 times 10.5 is 110.25 plus 14 squared is 196. Now we got to do 17.5 times 17.5. That equals 306.25. 306.25. And now I'm going to do 110.25 plus 196. That equals 306.25, which is equal to 306.25. So these last three numbers do form a right triangle. Okay? So that's how we verify if three numbers put together form a right triangle. Now, let's go ahead and move forward. Number 13, we have to solve for x. So for number 13, we're just going to use the Pythagorean theorem the way that we would normally use it. So let's label our parts. We have A, we have B, and we have C. Okay? So we're going to do A squared plus B squared is equal to C squared. Now we have to label our parts. A squared, that's 13 squared, plus B squared, which is 18 squared, is equal to C squared, which we don't know yet. So 13 squared is 169. 18 squared is 324. And that's supposed to be equal to C squared. Now, what we're going to do is add, okay, 169 plus 324, that's 493. Now, in order to figure out what C is, we have to, C is equal to the square root of 493. So I'm going to take the square root of 493, which is approximately 22.2. So I'm going to use my approximation symbol here, which is this squiggly line, okay? And it's approximately equal to 22.2. X is C, okay? All right, now for number 14, if we label this is A, B, and C. However, for number 14, they give us the hypotenuse in one leg. So we're going to have to use the converse here, which is C squared minus B squared is equal to A squared. C squared is 10, so 10 squared minus B squared, which is 9 squared, is equal to A squared. So that's going to be 100 minus 81 is equal to A squared. 100 minus 81 is 19. And so A squared is equal to 19. That means that in order to find A, we have to take the square root of 19. So A is approximately, square root of 19 is 4.35 or 4.36. Okay? So, and we found X. All right, so sometimes your answers may be still your answers may still be written as a radical, or you may have to simplify the radical by taking the square root, okay? Let's take a look at these last two, 15 and 16, and that will conclude our lesson for today on Pythagorean Theorem. Number 15 reads, a baseball diamond is a square with each base 90 feet apart. Andy is standing on first base while his teammate Logan is standing between second and third. If a straight line distance from Andy to Logan is 98 feet, how far is Logan standing from second base? Round your answer to the nearest tenth. So, let's go back to the first sentence. A baseball diamond is a square with each base 90 feet apart. So, I'm just going to draw a square. Okay. We'll say that this is first, second, third, and really we should go the other way around. Let me draw my baseball diamond correctly. So I'm still gonna draw a square, but I'm gonna put home right here. This will be first base, second base, and third base, and then he comes right back home. Now, the distance between each one of these is 90 feet. And 90 feet. Okay. It says Andy standing on first base while his teammate is standing between second and third base. Okay. So if a straight line distance from Andy, so Andy is here. Andy's on first base. Okay. Logan is somewhere between second and third. So Logan is over here somewhere between second and third. If the straight line distance from Andy to Logan is 98 feet, so from Andy to Logan, that's 98 feet. As a matter of fact, let me use a different color. Let's do yellow. So from Andy to Logan, that is 98 feet. Okay? And they want to know, what do they want to know? How far is Logan from second base? Okay? So the part of the triangle that we're really going to be the part of the triangle that we need to focus on is right here. This triangle here. Okay? And remember, inside of a square, all four corners are right angles. Okay? So we're only worried about the highlighted area. So I'm going to redraw it. And I'm going to basically be laying it down. So imagine if I was pulling this one down like this, right? Then it would be shaped something like this. Okay. So if I laid that down, here's Andy, right? Here's Logan. Our right angle is right here. This is second base. All right. And remember, over here is first base, where Andy is. This distance between them is 98 feet. And we know the distance between first and second is 90 feet. Okay. They want us to find out how far is Logan from second base. Okay. So we basically, if we were labeling this, we have C, this would be A, and we're trying to find B. So we have to use our converse because they gave us the hypotenuse and one of the legs. So our converse is C squared minus B squared equals A squared. But in this case, we need to interchange A and B. Okay, so it's really C squared minus A squared equals B squared. So now we're going to do 98 squared minus 90 squared equals b squared. So I'm going to pull my calculator out for this because these numbers are kind of large. 98 times 98, that is 9604. Minus 90 times 90, which is 8100. And that's equal to b squared. So now I'm going to do 9604 minus 8100. That equals 1504. Okay? So b squared is 1504. Then in order to find b is equal to the square root of 1504. So b is approximately, I gotta take the square root, which is about 38 point, they said round to the nearest 10th. So we have 7, 8, we gotta round that 7 up to an 8. So Logan is about 38.8 feet away from second base. Okay. All right. Now, let's take a look at number 16. If DC is 8.4, so D to C, this right here is 8.4. Then it says B to C is 30. And A to D is 42. A to D is 42. Find AB. Okay? So, what they want us to find is this here. Find AB. However, they gave us two triangles. Okay? So, we're going to have to, in order to find AB, they gave us 42 right here, but we don't know what this is. Okay, we don't know what BD is. So in order to find BD, we're gonna have to start with the smaller triangle. Okay, so once again, we have to know what BD is in order to find AB. All right, so remember, we have to find BD. So I'm gonna draw these two separately here. This is A, B, D, and then we have, matter of fact, I can move this one over here. Then we have B, D, C, okay? And remember, all of these are both right triangles, all right? Now, we need to find AB. So we're going to label AB as X for right now. All right. We know DC is 8.4, and we know BC is 30. And we know AD is 42. What we don't know is BD. And we know that both of these are equal. BD right here is congruent to BD right there. Now, in order to find AB, like I said, we need to find BD. So that means we have to do the work for the first triangle. So for the first triangle, for the smaller triangle, for triangle BDC, we have, let's label this. This would be A, B, and C. So we have to use the converse of the Pythagorean theorem. So the first thing we're going to do is do the converse, which is C squared minus B squared is equal to A squared. And we're going to do that for the smaller triangle. So that's going to be 30 squared minus 8.4 squared equals A squared. So let's bring the calculator back out. Working with the calculator, 30 times 30, 900. Minus 8.4 times, or matter of fact, let me just hit the squared. It's clear. 8.4 squared, that's going to be 70.56 equals a squared. Now we got to do 900 minus 70.56. That's going to equal a whopping 829.44 is equal to a squared. And a, we already know, a is equal to the square root of that number, 829.44. So I'm going to hit the square root button there, and that gives me 28.8. Okay, so now that we have a, I'm just going to remove the calculator real quick, go back to our diagram. So a, we now know a is 28.8. So 28.8. So I can put 28.8 right here. Now that we know 28.8, we can go ahead and do the second part. Okay. Our second part is using the Pythagorean theorem, because if we label our triangle again here, the smaller one, the bigger one, this would be A, this would be B, and this would make C. Okay, so we have to use our regular Pythagorean theorem, which is going to be A squared plus B squared equals C squared. So A is 42, so we have 42 squared plus B is 28.8 squared equals C squared. Okay, so all right, so now that we have 42 squared plus 28.8 squared equals C squared, we can go ahead and do the math and work those out. So let's pull the calculator up. 42 times 42, that's 1764. Let me fix my pencil. So 1764 plus 28.8 squared, that's going to be 829.44. I'm going to add those. It's going to give us 2,593.44. And then to get our final answer, we're going to take the square root of that, which is approximately, says to the nearest tenth, so 50.9. All right. And what were the units here? Oh, just 50.9. All right. That will conclude this video, and we'll see y'all next time. Deuces.